Okay, hey guys, so today I wanted to quickly do these two fairly basic exercises on group theory. So the first one asks us to show that for any triplet of elements ABC in a group G, there is, if we have the equality A times B is equal to A times C, this would imply that B and C are equal. Now, we can let's take this equality and try to get to this one. So take this equality and we multiply on the left by the inverse of A, which is something that we can perfectly do because this is a condition on the group. There must be, for every element, there must be an inverse element. So we can do that. Okay. Now, due to associativity, we can move the brackets here. Okay, now due to the property of the inverse, the elements here within the brackets become the unit element. Let's denote the unit element by E, I'm sorry. And now we just apply the property of the unit element that any element times the unit element is that element again. And we're done. Okay, now for the second exercise here, we are asked to show that for any pair of elements from a group G, there exists a unique C for which it holds that A times C is equal to B, where the pair is AB. Okay, so let's see if we can construct this. Let's start with B. We can multiply on the left by the unit element due to the property of the unit element, the defining property. Now the unit element, we can interchange it with A and its inverse. Both should exist in the group. Now, due to associativity, we can move the brackets. And if we now call this element within the brackets C, we have found our element C. Now, to prove that this element is unique, we simply say, imagine there is another element for which this holds, namely C prime. A times C prime is equal to B. Well, A times C prime would be equal to A times C. And because of our earlier exercise, C prime would in this case be equal to C. And we're done.